Hey, Alyssa, this is Miss Tracy. I wanted to respond to your messages about problems in lesson 59, I believe it was. So it looks like there were 3 of them, and this is one of them here. So the first thing we need to do is find that common denominator. And in looking at these, our common denominator is going to be y squared times a plus y. All right, and you found that, and that one was marked correct. You got that answer right. The problem that you didn't have, or the part of the problem that you didn't get credit for, was the numerator. So let's look at what the numerator is all about. So if we multiply this times what's missing in each one, what we get for the first one is x and y both need to be multiplied by ay times a plus y. And the same thing here, ay times a plus y. Plus, and then we have x squared plus 2 over y squared a. So we already have this part in the bottom, but the denominator needs to be a plus y times a plus y, right? So that makes this the same as this. Now the last one is x cubed, and it already has y, a plus y in the bottom. So it needs an a and a y. So times ay in the top and the bottom. So that, and this looks more like a 9. Let me change that. So that now they all have the same denominator. We just need to do a little bit of calculation. So I'm going to rewrite it. And our denominator is y squared a times a plus y. And we'll leave it just like that. And we're going to just resolve some of these. So this is going to be axy times a plus y plus x squared plus 2 times a plus y plus we'll just write this all together, ax cubed y in alphabetical order. So this is what your numerator is supposed to be. So you have the option to leave it like this, but you also have the option to type it in a simplified format where you've done all the distribution. And I believe that if we do that, it's going to get really long and drawn out and complicated. So we can just leave it like this and type it in. And it would be fine just like that, okay? But if you wanted to solve it the other way, right? Let's move this over a little bit and up. So let's simplify this if we can. So if we simplify this, we get a squared xy plus ax y squared. That's this first bit. Plus, then we're going to get ax squared plus x squared y plus 2a plus 2y. And that's from this bit right here. And since there's no negatives, I can just go ahead and get rid of these parentheses because it's not going to change anything because they're all positive. All right, and then we just have that final term, ax cubed y. So you have all of these terms, and I don't see any that we can combine. I don't see any at all that are alike. So they're all just these terms over y squared a plus y, or if you're doing it in alphabetical order, that would be ay squared, right? Either one of those would be right. So I believe it's easier to type it in this way because there's fewer exponents for you to have to type. You only got 2 exponents as compared to 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5, 6, 7 terms versus 6, basically. So it might be easier to just type it in the way that it falls. And like I said, you got the denominator right, you just didn't have this part right. So go back and redo that one and it should be just fine. All right, so here's another one that you got part of it right. You got the length right, but you did not get the degree of measure right. So we want to convert this to polar form. So this tells me I've got a negative 4r, which r is my x term, and negative 2u, u is my y term. So negative negative tells me that that's going to be in the third quadrant. So I'm going to draw my little area here, right? And negative from 0, negative 4 would be about 1, 2, 3, 4, be about right there, and negative 2, 1, 2, be about right there. So this is where my point would be, right? And so I would draw my hypotenuse there, and then I'd make my little dotted line. So this is going to be 4, and this is going to be 2. And the negative only serves to tell us where it's located, right? We know that. But it also serves to help us determine, or the negative doesn't, but the 4 and the 2 tells us what the length of our legs are. So we can use Pythagoras' theorem to find the length of our leg, our hypotenuse. So 4 squared plus 2 squared equals c squared. So 16 plus, that's a 6, I promise, plus 4 is equal to c squared. 20 is equal to c squared, and square root of 20 is equal to c. We know that's 4 times 5. Square root of 4 is 2 times the square root of 5. That is the value of c. So that's what we want for c. 2 times the square root of 5, which it looks like you got that right. Let me double check here. Yeah, you got that part right. No problems. All right, so now we have to find the degree of measure, right? So that would go in here. 2 times the square root of 5, and then we have the slash, and then this part is the degree of measure. So that's where we've got to find here. So I know that this is 90, and this is another 90. So it's going to be 180 plus whatever theta is here. And that's going to equal my degree. We'll call this D for degree. All right. It's actually V for vector. Let's do V for vector. Or magnitude. So that's going to be my V right there. All right. So 180 plus whatever theta is here, because this is 90, this is 90, so that's 180 plus this theta, whatever that is. So now that we know that this is 2 times the square root of 5, we can put that length in there. And now we can use sine cosine to find this degree of measure. So I'm going to use sine. Sine is opposite over hypotenuse. So the sine of theta is equal to, opposite would be 2 over 2 times the square root of 5. So now, in order to solve a little bit more, I am going to actually, you know what? I'm not going to use sine. I am going to use tan. So the tan of theta, I don't know why I thought I'd use sine, is going to be TOA, which is TOA, opposite over adjacent. So the opposite is 2 over the adjacent 4. So that is 1/2, right? That's 1 over 2. The tan of theta is equal to 1/2. However, that doesn't tell us what theta is. That only tells us the tan of theta. So we have to get the inverse of this number, the inverse tan of this number, in order to find what theta is. So you have to use your scientific calculator. Let's pull that up. And the way you do that is you would say, first of all, you perform the division. 1 divided by 2 is equal to 0.5. And now we want to get the tan of theta, the inverse tan of theta. So you go to the second key and you do that tan negative 1. That's the inverse of tan. Click that button and you hit equal. And that is going to be, oh, hang on. 1 divided by 2 equals tan of theta. That's your answer right there. You don't hit equal. You stop right there. So 26.56, we round that up. That'd be 26.57, right? So theta is equal to 26.57 degrees. Okay? The tangent of theta is 1/2. Theta is 26.57 degrees. That's that little thing right in here. We have to add that to 180. So 180 plus 26.57 degrees is equal to 206.57 degrees. So that is what goes where V is. 206.57 degrees. So you can't just find the tan of theta. We have to find theta. And in order to do that, you have to get the inverse of the tangent. Okay, so you use that inverse tangent button on this calculation. And then that's going to give you the degree of measure of the problem. All right, and then you have to take into account where it's located on your Cartesian coordinate system. And like if it were located here, you would add 90 degrees to it because it's 90 plus whatever that degree of measure is. But because it's in the third quadrant, we added 90 plus 180 to this degree of measure here. If it had been over here, we would have added 90, 180, 270 to whatever that degree of measure is. So that's how you get that, okay? You find theta, and then you add to it the previous quadrant degrees. All right. Okay, let's look at the next one you had a problem with. All right, so this was another one of these conversion problems to polar form. So you got the degree of, or the length of the hypotenuse. This was correct. You found that. So we don't have to do that step. You can find that just fine. You've got Pythagorean's theorem down pat. It's the other part that where the degree of measure, theta, converting it to the degree of measure, not the tangent, right? So let's draw our little picture here. Because it's negative, negative, it's going to live in that third, right? So it's not here, it's not here, it's here. So -3 would be 1, 2, 3, and then 1, 2, 3, 4, 5. Whatever that is, that would be here. -3, -5, right? So this would be R. So R is 3. And this little thing right here, the U is 5. And then our vector is right here. And we've already found the length of that to be the square root of 34 right here. I'm just going to, because I'm hard-headed and I have to figure out everything for myself. That's 9, that's 25. Okay, that's 34. All right, yes, just double checking. Even though the system said it's right, I like to do it myself. So square root of 34 is the length of the hypotenuse, right? We know that. This little guy in here, this angle is theta. So we're going to use TOA, tangent, right, to find theta. So the tan of theta is equal to opposite over adjacent, so 5/3. So we do the exact same thing we did before. We pull up the calculator. This is one of those things you just have to use the calculator for. Okay, and we do 5 divided by 3 equals. And then we hit the inverse tan, or that tan -1. And our degree of measure is 59.04, because we're rounding to 2 places, as is our standard. So 59.04 is theta. Now, we have 90 degrees here, because we measure from this x-axis here and all the way around. So it's 90 here, 90 here. So we've got to add in this theta degree here. So that's going to be 180 plus 59.04. And that's going to be 239.04 degrees. So, square root of 34, 239.04 degrees. And that would be how you do that. And you see, it's not a whole lot of math. You're not really doing a whole lot of steps here to get that. You just have to use the calculator to get there. So remember, we use, in order to get theta, we have to use the inverse tan key, right? That's what you're going to do. So in the calculator, we said 5 divided by 3 equals, and then we did the tan -1, or whatever your inverse tan key is. And then that is going to give you your 59.04. That's what you put here for the degree of measure of theta. Then you take that, and that's just in this quadrant. So because we measure from x, you have to add every previous quadrant to that degree of measure so that you get the right one. Because think about this, like kind of like radar. You have to think about it like that. It's radar. It starts here and it sweeps around, right? And in order to tell exactly where it is on that radar system, like for a submarine or whatnot, it's going to give the degree of measure from a starting point all the way around. Not just in this one little quadrant, but on the whole circle. So it's going to live within 360 degrees. So as it sweeps around and sweeps around, you get that little blip out here. You know, they got the other little enemy ship coming, and this is the vector that it's at, and we're sitting right here. This is where he is. He's 239 degrees. Well, when the submarine radar guy says a vector of 239 degrees, and you know, he would perform that calculation and he would say 5.2 kilometers away at 239 degrees. Then they would know exactly where he is, because that's what they're thinking about. They're thinking about a plane of location from where they are. And that's going to be there in the center. And then these other submarines or planes or whatever it is that they're tracking, they know where they're located in relationship to them, right? They know they're back here. So that's what we're doing. We're learning how to track things in relationship to the center of something. And, you know, like a clock, or, you know, it's a reverse clock because it goes counterclockwise, but still, that's how radar works. And that's what we're learning how to do. We're kind of understanding that whole process. So you have to add in those other quadrants in order to get the right degree of measure. So I hope I've painted you a picture that allows you to understand more of why we're doing that and how that's supposed to work. If you have a clear understanding of the application, sometimes it helps, I think. So anyway, if you have any other questions about this, please let me know. And also go watch a couple old war movies where they show, you know, submarine battles and they're doing that little radar thing. It's kind of cool because then you go, oh, I know how that works. And it's kind of fun. So anyway, ask for more help if you need it. I hope you have a great Christmas and a good break. And I'll see you when we get back. Bye, sweetheart.